Students, in this lecture also I'm going to continue with the programmable interrupt controller 8259. So I'll be discussing the interrupt sequence, how the interrupt requests are being serviced through this 8259 by the 8085 microprocessor. I'll discuss the whole procedure, the whole events that occur in an 8085 system. So first, what happens? One or more of the interrupt request lines. As you can see, this interrupt request register are having 8 interrupt request lines. So one or more of the interrupt request lines, this IR0 to IR7, are raised high, setting the corresponding IR, that is interrupt request register bits. So once among this 8, if all the 8 gets high, then it's okay. If any of this pins gets high, then also it is okay. What it will do, it will set the corresponding interrupt request register bit. Next, what happens? The priority resolver checks 3 registers: IRR, that is interrupt request register for interrupt request. It will check the interrupt mask register for masking bits, and it will check the interrupt service register for the interrupt request being serviced. Then it will resolve the priority, and it will decide which interrupt will get to service, which interrupt register bit will get to service, and sets the INT pin high when it is actually appropriate time to do so. Now once the INT pin is high, in response to this INTR signal, 8085 completes current instruction cycle and executes interrupt acknowledge cycle, thus giving an INTA bar pulse. Now upon receiving an INTA bar pulse from the 8085 microprocessor, the interrupt service register, this interrupt service register, the highest priority interrupt service register bit is set, and the corresponding IRR bit is reset. What I'm trying to say is, once the microprocessor acknowledges that it is going to service the interrupt, what happens inside the 8259, that the interrupt service register is set for the corresponding IRR bit which is going to get serviced, and how it gets to know which bit to set, which interrupt request or which interrupt register request is going to get serviced. How interrupt service register knows? It knows through this priority resolver, which sets it after checking all the 3 registers, which is masked, how many interrupt lines are being requesting the service, and how which interrupt service is being executed upon checking these 3. The priority resolver resolves and tells which interrupt request register will get serviced now, and according to that, interrupt service register will get set for that corresponding interrupt request register. And once it gets set, the corresponding IRR, that is interrupt request register, will be reset here. Now what happens? Now once the interrupt service register is set, what 8259 will do? It places the opcode for call instruction, the opcode for call instruction of 8085 microprocessor on the data bus, and it will send it to the data bus. So it will send the opcode of 8085 microprocessor through the data bus to the 8085 microprocessor. Now this call instruction, it will initiate 2 more interrupt acknowledge cycles. So these 2 interrupt acknowledge cycles allows the 8259 to release pre-programmed subroutine address. Means there is a program which is written previously, which is written earlier. So that pre-program, that small program, or that subroutine program is actually stored in the memory associated with the 8085 microprocessor. So what will 8259 will do? It will release the pre-programmed subroutine address onto the data bus. So in response to second interrupt acknowledge pulse, 8259 will place the lower byte of that interrupt service routine address, and in response to the third interrupt acknowledge pulse, 8259 will place the higher byte of the subroutine address. So what is happening? Once in the first interrupt acknowledge cycle, Let me again show you here what is actually happening. After getting the INTR pin, interrupt request pin high, 8085 will acknowledge it and will send the first INTA bar pin. So upon receiving the INTA bar pin, that is interrupt acknowledge signal high, 8259 will send the opcode through this data bus. Now once 8085 receives the opcode, it will again assign two interrupt acknowledge cycles. So upon receiving the second interrupt acknowledge cycle, 8259 will send the lower byte of the memory address where the program is written to, which is going to be get executed, the subroutine program or the interrupt program, you can say. And in the third interrupt acknowledge cycle, the higher byte of that memory address, where the subroutine program is written, the higher byte will get through this data bus. Now this completes the interrupt cycle. In the automatic end of interrupt mode, this ISR bit which was set means the interrupt request which is being serviced, that ISR bit will be reset at the end of the second INTA bar pulse. Otherwise, the ISR bit remains set until the issue of appropriate end of interrupt command at the end of interrupt subroutine. Now coming to the priority modes of 8259. So there are 5 priority modes: fully nested mode, special fully nested mode, rotating priority mode, special mask mode, and pole mode. So in fully nested mode, after initialization, this 8259 operates in fully nested mode. It is also called default mode. So 8259 continues to operate in fully nested mode until the mode is changed through operation command words. So in this mode, what happens? IR0 means, here you can see also, in this fully nested mode, this IR0, it is having the highest priority, and IR7 is having the lowest priority. And when the interrupt is acknowledged, it sets the corresponding bit in interrupt service register. So this bit will inhibit all the interrupts of the same or lower levels. What I'm trying to say is that if IR0, IR1, IR2, all the 8 pins are high requesting the interrupt service, what will happen? IR0 is having the highest priority by default mode or by fully nested mode. So IR0, the corresponding bit of IR0 pin will get high in interrupt service register, and that will get serviced. So this bit is high, it will inhibit all the interrupts of the same or the lower levels. It will inhibit all the interrupts of the same or lower levels. However, it will accept higher priority interrupt requests. So the vector address corresponding to this interrupt is then sent, and the bit in the ISR, that is interrupt service register, will remain set until an end of interrupt command is issued by the microprocessor at the end of interrupt service routine. But if automatic end of interrupt bit is set, the bit in the ISR register resets at the trailing edge of the last INTA bar pulse. Next mode is special fully nested mode. In the fully nested mode, on the acknowledgement of an interrupt, further interrupts from the same levels were disabled. So this was one drawback, you can say, of fully nested mode, that on acknowledgement of an interrupt, further interrupts from the same level are disabled. Means if IR3 is being serviced in the fully nested mode, then further request into the IR3 will not be serviced, it will be disabled. Further interrupts from the same level are disabled. Now consider a large system. Consider this large system where 8259s are working as master as well as in slave modes, which uses this cascaded 8259s, and where the interrupt levels with each slave have to be considered. So what happens? An interrupt request to a slave in turn causes the slave to place an interrupt request to the master on one of the master inputs. Further interrupts to the slave, as we can see, a slave is also having 8 interrupt requests, and once the slave gets the interrupt request, it will go to the master. It will go to the master for service. So once if it is getting serviced in the master, then further interrupt request to the slave what will happen. Further interrupt request to the slave will cause the slave to put request to the master on the same input to the master, but this will not be recognized in fully nested mode because further interrupts on the same input level are disabled by the master. So the spatial fully nested mode is used to avoid this problem. What happens in spatial fully nested mode? When an interrupt request from a slave is being serviced, the slave is allowed to place further requests if these requests are of higher priority than the request currently being serviced. Again, let me show you with an example. If IR4 interrupt register 4 IR4 is being serviced by the slave through this master, this slave is connected to the master through this pin, IR0 pin. This IR0 is connected to the INT. So if suppose IR4 is being serviced through the slave through the master, then what will happen? If any interrupts that is of higher priority than IR4, suppose IR0 to IR3, they are requesting for service, then that will be recognized by the master if it is coming to the even if it is coming to the same interrupt input like IR0. So this is the advantage of spatial fully nested mode. Now the next mode that I'm going to talk about is rotating priority mode. So in this mode, what is happening? A device after being serviced receives the lowest priority. The device just been serviced will receive the 7th priority. Here IR3 has just been serviced. What is happening? These are all the 8 interrupt requests of the 8259 programmable interrupt controller, and if suppose IR3 has been serviced, then it will be assigned the lowest priority, and then the next interrupt and then the next interrupt request registers will get the highest priority. So IR4 will have the highest priority. In this way, sequentially all the interrupt register priorities will be set. Similarly, if IR5 is being serviced, then it will be assigned the lowest priority, and the next IR register will be assigned the highest priority, and in this way all the register interrupt priorities will get set. In rotating priority mode, we have another priority mode, that is specific rotation. So in automatic rotation mode, the interrupt request last serviced is assigned the lowest priority, as we have seen here. Whereas in specific rotation mode, the lowest priority can be assigned to any interrupt IR0 to IR7 and thus fixes all other priorities. For example, if the lowest priority is assigned to IR2, other priorities are shown below. So here what happens in specific rotation mode, specifically we can assign any priority. Specifically we can assign the lowest priority to any of the interrupt request register, and in the same way what will happen, other interrupt request register will get their priorities automatically. If IR2 is 7, the lowest priority, then the next interrupt request register will have the highest priority, and automatically all the interrupt request registers will get their priorities. The next mode that I am going to discuss is spatial mask mode. So if an interrupt is in service, then the corresponding bit is set in ISR, as that I have told you. If any interrupt request register is in service, then the corresponding bit in the ISR register is set, and the lower priority inputs are inhibited. Now, some applications may require an interrupt service routine to dynamically alter the system a priority structure during its execution under software control. For example, the routine may wish to inhibit lower priority requests for a portion of its execution but enable some of them for another portion. So in this cases, we have to go for special mask mode. In the special mask mode, what will happen? It inhibits further interrupts at that level and enable interrupts from all other levels, lower as well as higher, that are not masked. And the last mode is pole mode. So in this mode, the INT output is not used. The microprocessor checks the status of interrupt request by issuing the poll command. The microprocessor reads the content of 8259 after issuing the poll command. During this read operation, the 8259 provides polled word. What happens? The 8085 microprocessor, it checks the what during this process. What happens? 8085 microprocessor issues a poll command to the 8259, and then 8259 sends the sends the status word. It sends the status of interrupt request like this, and then microprocessor reads the content of 8259 after issuing the poll command. So during this read operation, the 8259 provides this poll word. So this 8259 provides this polled word and sets ISR bit of highest priority active interrupt request format. So here I is equal to 1 means one or more interrupt requests activated. I is equal to 0 means no interrupt request activated, and W2, W1, W0 is the binary code of highest priority active interrupt request. So again I am repeating what happens after 8085 issues the poll command to 8259. 8259 sends the polled word to the 8085. This is the polled word, the format of the polled word. Here I, if it is 1 means one or more interrupt requests are activated, and if it is 0 means no interrupt request has been activated, means all the IR0 to IR7, no request has come to the IR0 to IR7 pins of 8259. No pin, these pins are deactivated, matlab no request has come. Now if it is 1 means requests have come, and which is having the highest priority among IR0 to IR7 request pins, it will be given by this binary word. Binary code of highest priority active interrupt request will be here, and these are undefined. So this is all about programmable interrupt controller. I am ending this class here. Thank you.